there. Welcome to Algebra for the week. We are going to be working on completing the square. It's an important way to be able to solve a quadratic equation. There's many ways to solve quadratic equations, but this one works well a lot of times. And so if we're going to be completing the square, it might be a good idea to understand what we're talking about when we talk about a square. Today we're going to be completing and making perfect squares. Okay, perfect squares. So let's review. What are perfect squares? Well, there's lots of perfect squares in numbers. Let's look. 4. 4 is a perfect square because it's the same as 2 times 2 or 2 squared. Right? So 4 is a perfect square. A perfect square is any time you can take a rational number, multiply it by itself, and you come up with a perfect square. Or a binomial multiplied by itself. Binomial, 2 terms, like x plus 1 squared. So what the product of that would be a perfect square. So other perfect squares, 9, 3 times 3, 3 squared. 16, which is 4 squared. 25, 36, 49, all the ones where we can take 2 squared, 3 squared, 4 squared. Even 1 is a perfect square because it's 1 times 1, right? So that is a perfect square. But don't forget, like 1/4 is a perfect square because 1/4 is 1/2 times 1/2, and that is 1/2 squared. So we can do that with fractions because those are rational numbers also, right? With a binomial, if we had the x plus 1 times x plus 1 multiplied together, that's x plus 1 squared. But when we multiply those together, it'd be x squared plus 2x plus 1. So x squared plus 2x plus 1 is a perfect square. And that's what we're going to look at creating today with our quadratic equations, is completing the square and be able to solve those and find what does x equal for those equations. So, without further ado, or further discussion of perfect squares, whichever you like, let's switch over and take a look at our lesson. All right, completing the square, part 1. We'll be continuing this next lesson. Perfect or imperfect, all right? So select all the expressions that are perfect squares. We just talked about perfect squares and explain how you know. This is x plus 5 times 5 plus x. Is it multiplying the same thing times itself? Well, this is the same thing just rearranged. They're both positive x's and positive 5, so it's either x plus 5 and 5 plus x. It's like 2 plus 3 and 3 plus 2. It's the same thing. We just rearranged the order. So this is perfect square. How about the next one? X plus 5 times x minus 5. Is that a perfect square? That's not multiplying the same thing times itself. That's multiplying two different things, not a perfect square. How about x minus 3 squared? Well, it's obviously a perfect square because it's multiplying x minus 3, times x minus 3. So it creates a perfect square. How about x minus 3 squared? Ooh, this is where we get into that problem when we don't use parentheses in the calculator when we want to square something. This is only squaring the 3. It's not squaring everything. So this is the same as x minus 9. So that is not a perfect square. That is only squaring the 3. Without those parentheses, it's not taking the entire thing and multiplying it times it. X squared plus 8x plus 16. Is that a perfect square? Are there two binomials that are the same binomial that we can multiply together to get that? Well, let's see. Remember how we created these by we had to multiply together. And the middle term, when we multiply the last term, is the same number by itself if it's a perfect square, right? And that number would add to itself to be the middle term. So what number multiplies times itself to be 16, but adds together to be 8? If I put the little thing over here, I need one that adds to be 16. Multiplies to be 16 and adds to be 8. Well, it's obviously 4 and 4. 4 plus 4, 4 times 4. So this would be the same as x plus 4 squared. Perfect square. Perfect square. Remember, get the middle term. If it's a perfect square, the middle term would be the same number added to itself twice and the same number multiplied by itself to get the last term. And that's what we have on that one. Make sure it's staying in focus. It's... Ooh. Am I staying in focus? All right. X squared plus 10x plus 20. Let's look at that. So 10x would have to be the same number added to itself. So what number adds to itself to be 10? Well, that would be 5, right? So what's 5 times 5? It's not 20. Not a perfect square. This would have to be x squared plus 10x plus 25. That would be the perfect square, right? Because that would be 5 times 5 and 5 plus 5. Okay, so let's not forget that on perfect square trinomials. Follow that pattern. The same number added to itself, multiplied by itself. Same number. This is important for perfect squares. All right, so now we're going to do a little work in creating perfect squares, building one. We're going to complete the table so that each row has equivalent expressions that are perfect squares. So, starting out, we have, I'm going to bring this down and get this a little bigger on the screen. Make sure we can see what is going on here. Got the big shadow. All right, we have the standard form on the left, and we have to put the factored form on the right for the first one. So it's x squared plus 6x plus 9. Okay, what number adds to itself, which basically just means cut this number in half. What's half of 6? 6 divided by 2. Be 3 plus 3. Well, 3 times 3 equals 9. So 3 must be the constant number, the x plus the 3 squared. Right? X times x is x squared. 3 times 3 is 9. 3 plus 3 is 6. All right, the next one, what do you think it's going to be? Let me give you a second to look at that. Minus 10 is the coefficient of our x. Minus 10. That's going to be minus 5. Because minus 5, and then we're going to square it to be our factored form. Minus 5 plus minus 5 is minus 10. And minus 5 times minus 5, remember a negative times a negative is a positive, plus 25. All right. So that is the factored form for that equation. And number 1, now they're going to have us go the other direction. X minus 7 squared. Well, knowing how this works, we should be able to do that somewhat simply. Minus 7. So minus 7 plus another minus 7, minus 14x. That's our middle term. Middle term. Last term is multiplying minus 7, negative 7, times itself, which would give us a positive 49. All right, that making sense? If you're not understanding that, anytime feel free to pause the video, back up and look at that again and see if you catch something different this time. You can always do that. That's the nice thing about online is you can kind of go at your pace on that. All right, let's look at this. This, they don't give us either one. They give us part of it, and they give us part of this, and this is the rest of the way down. But we have enough to figure that out because we know for it to be a perfect square, the middle term would be cut in half, would be the same number added to itself to get the negative 20. So negative 20 would have to be negative 10. X minus negative 10. We know that's the same thing as x plus 10, right? X minus 10. Oh, maybe they gave us the minus because it's all the same thing. It shouldn't be x plus 10. It should be x minus 10. They already put the minus to kind of give us a hint. What is negative 10 times negative 10? Well, 10 times 10 would be 100. It's got to be a positive, right? So x minus 20x plus 100 would be x minus 10 squared. All right, x minus 10 squared. Or plus a negative. That's what I was thinking. X plus, but it's a negative 10. Okay, the rest of these are all positive. So if this middle number, the middle is positive, it's going to be a positive. If the middle is negative, that's when you're going to have a minus. Okay, so positive will be add, negatives will be subtract. 16. What number adds to itself? What's half of 16? This has to be 8. And then 8 times 8 would be 64. See how that works? How about this one? 7. What's half of 7? You're like, it's a fraction. You could just write as 7 halves. It's also 3.5, but then you got to multiply 3.5 times 3.5. You can get more decimals. If we leave it as this, 7 halves. So what's 7 halves times 7 halves? Remember, with fractions, when you multiply fractions, you just multiply straight across. So it'd be 7 times 7, 49. 2 times 2, 4. So this is 49 over 4. 49 over 4. So for you decimal people, you'll end up with a 12.25, right? 12.25. But 49/4 is an exact answer that's easy to do because it's just 7 times 7 and 2 times 2, and we don't have to mess with any decimals and have to get into the calculator that way. This is just generically any perfect square trinomial. X squared, where b is our middle one. Well, that would just be whatever b is divided by 2. All right, b divided by 2. And so this would be b times b, multiplying straight across, b squared over 4. B squared over 4. 2 times 2, b times b, right? B squared divided by 4. So that would be generically how we would do any of these. We just take this number, cut it in half, and then multiply it by itself to get that last one. All right, if you still struggling with that, look at this again. Remember, Mrs. Smith and I are online every weekday. We have office hours that we get online and we sit in the chat room and we wait and see if anyone needs some help. And we also, by email, can set up appointments to where if it's not a convenient time for you when we're online, we could get online at a different time of the day. Be happy to do that. We could set up an appointment with you. Fridays is our extended tutoring. We don't have a lesson on Fridays now. It has changed. We have lessons Monday, Tuesday, Wednesday, Thursday. Friday's a tutoring day. So Friday, I was online. I think I stayed online 5 hours this past Friday. Just in an online chat room. It's posted in Google Classroom. You can go click on the link and come ask me anything that you need to know on that. Any questions we can do. We're going to work on retakes through Friday tutoring. We can do that online while we're together and anything like that. So come visit with me this week. We're online. My hours this time. Check them. I'm going to probably be more in the mornings. I did that survey last week on the attendance sheet, and most people are in the mornings. There's a few people in the evenings, but when I did an evening chat the other day, I didn't have as many people as I do during the day. I may do one evening, one a week, just because I don't want to leave you folks out altogether if you're not doing any work in the morning. So, but I will be on more in the mornings than the evenings. So let's look at this. Diego and I each solved this problem in a little bit different way. Completing the square. This is going full-fledged into solving one. So they had this problem. X squared plus 10x plus 9 equals 0. Okay, and this is what Diego did. He said, I'm going to move the 9 to the other side because that's not a perfect square. We're trying to solve this using perfect squares. Yeah, we can solve it other ways. Like I said, there's more than one way to solve a math problem, especially quadratic equations. But with this, we're using completing the square. And this is how we're doing it. Since this is not a perfect square, right? Because to be a perfect square, it would have to be what? 10x is the middle. So we'd cut the 10 in half. It should be plus 5. Right, x plus 5 times x plus 5 would make that a perfect square. It wouldn't be plus 9 at the end. It'd be 5 times 5. So this is what he does. He moves the 9 to the other side. He says, okay, I'm going to leave that up there. And what I'm going to do is I'm going to see what does it take to make that. There where we said we add that 25, right? Because to make this a perfect square, x squared plus 10x, if we cut that in half, it'd be 5 plus 5. And then the last term would be 5 times 5. So he says, I'm going to add that 25 on there and make it a perfect square. Now, of course, since it's equal to negative 9, it's not going to be equal if we add 25 and don't do anything here. So we also have to add 25 to the other side. So now our equation's still equivalent to the original equation. We've not changed anything. We have kept that balance between the two sides. So we added 25 to both sides, the same number. Keep it even. So he said, okay, so the next step, all he did was some math. Negative 9 plus 25 is 16. So you see that? Nothing changed over here. We just simplified negative 9 plus 25. Now in this step, now that we have a perfect square, he said, what is that? It's x plus 5 squared. That's what the perfect square is. That's the roots of that square, right? That's the two numbers the two binomials in this case, that we'd multiply together to get that perfect square. So it'd be x plus 5 times x plus 5, or x plus 5 squared. So we know that x plus 5 squared equals 16. So here's where it gets pretty cool. So he said, well, that would mean x plus 5, since I'm multiplying it by itself and getting 16, what number multiplies by itself to get 16? Well, 4. He said, that means x plus 5 has to be 4, right? Because 4 squared is 16. 4 times 4 is 16. But we can't forget, it could be negative 4. Because negative 4 times negative 4 also equals 16. So he said it has to be either x plus 5 equals 4 or x plus 5 equals negative 4. Because either one of those would make that equation true. So if x plus 5 equals 4, he subtracted 5 here, he subtracted 5 there. And when you subtract 5 from both sides, x equals 4 minus 5 is negative 1. So that's one of the solutions. It could be negative 1, or x plus 5 equals negative 4. Subtract 5, negative 4 minus 5, x equals negative 9. Wow, that works wonderfully. We got the same solution. If we factor that, this is x equals negative 1, x equals negative 9. Because if we took negative 1 times negative 9, it'd be positive 9. And if we add it, remember when we did that, it's x minus a number. It'd be x minus a negative 1. So the factor, it would end up x plus 1, x plus 9. All right, that would be the two factors. X plus 1, x plus 9 equals 0. Using these solutions, bring that down a bit. Using those two solutions, that would be the equation. Because if you said x plus 1 equal to 0, x would have to be negative 1. Because negative 1 plus 1 equals 0. Or negative 9 plus 9 would equal 0. So that is the two solutions. Those would be the factors. And we know that 1 times 9 is 9, and 1 plus 9 is 10. So those are the factors. But we used completing the square to get there. And it worked nicely on this, and we could have factored that, but that's not usually going to be the case. A lot of times you're going to get a number that you cannot factor it just straight off. So that's why we're learning this method. Maya did something very similar. But what she did was left it equal to 0. And she said, how much more do I need for this to be a perfect square? All right, it should be, if this is 10, it should be 5 times 5, 25. I've only got 9. I'm going to add another 16 so that I have 25. And then she added it to the other side to keep that equal. Then she ends up at the same place as Diego did right there. That's the only difference. Diego moved that 9 to the other side because he said that doesn't work as a perfect square, so I'm going to move it to the other side. Then I'll just add what I need. She said, I'm going to figure out what I need, and then I'm going to take the difference and just add that extra piece. Either way you like. It's the same thing. As you can see, it doesn't take long to get to the exact same thing. So it may be easiest to just move it to the other side and add that number you need, rather than trying to figure out what did I have, what do I need to add to get to what I need. Probably so. Let's try working one right here. Let's study the worked examples. Okay, we've looked at those, we've analyzed those, and then try solving these equations by completing the square. All right, so looking at this, I'm going to raise it up a little bit. Make sure I'm kind of in focus. That would be good. Okay, give ourselves some room to work. X squared plus 6x plus 8. All right, is that a perfect square trinomial to start off with? Well, we got to check right here. 6x, so that means would be a plus 3 and a plus 3. And 3 times 3 is not 8. This is not a perfect square trinomial. So I'm going to move that 8 to the other side. All right, going to subtract 8 from both sides. We're going to move it. X squared plus 6x equals negative 8. Now notice I gave myself some space in there, because this is where we're going to figure out what do we need to be with that x squared plus 6x to make it a perfect square. trinomial here, plus 6. So we said that was 3 plus 3 equals 6. So 3 times 3 would be 9. So I'm going to add that here, and I'm going to add that here. All right, we have to add it on both sides. So let's do a little math here. I'm going to leave that alone for now because I want to do some math over here. Negative 8 plus 9. That would be a positive 1. Okay, so now we have this to a perfect square trinomial, and it equals 1. So let's break that out into the factors. That would be x plus 3 times itself. So I'm going to square it. X plus 3 squared. And it will equal 1. So if x plus 3 squared equals 1, then that must mean x plus 3 equals 1, or x plus 3 equals negative 1. All right, because 1 times 1 will equal 1, or negative 1 times negative 1 will also equal 1. So if x plus 3 equals 1, we can subtract 3. X equals 1 minus 3, negative 2. Over here we subtract 3. X equals negative 4. Wonderful. That's the solutions. So the solutions for this original x squared plus 6x plus 8 are negative 2 and negative 4. That's our two solutions. All right, let's try another one. And let's see what we have. We have 5 of them. Tell you what, interest of time, I'm going to do 3 of them, and then I will let you work on that. We won't do the Are You Ready for More? I don't want the video to be too long, but I'll turn you loose on the assignment, because this should be all the information you would need for that. If you're having trouble, let me show you one thing you can do. That x squared plus 12x. If you're having trouble figuring that out, all right, remember when we did the box and we tried to figure out the factors that we would multiply. This is an x, this is an x, that's an x squared. And we know this is a 12x. So we would have half of it here, 6x, and half of it here, 6x. All right, because we're just cutting that in half. Instead of a 12x, we got 2 6x's. Because put those together, we got our 12x. So x times x was x squared. What would x need to be multiplied to be 6x? Positive 6. What would x need to multiply to be 6x? Positive 6. So that tells us the last box is 6 times 6, or 36. See how that works? Kind of gives us the numbers we need right there. So on this one, we've already got the number on the other side, which is wonderful. We don't have to move that. So if we add our 36, oh, I forgot the x in there. Let me make sure I got some room. The 12x, don't forget your middle x. X squared plus 12x plus 36 equals 13. And I have to add it to both sides. Remember, if I did it to one side, I got to do it to both sides. 36, 36. So we can simplify both sides. This side we know simplifies to this. It's x plus 6 squared, because it's x plus 6 times x plus 6. And the other side is 13 plus 36. That is 49. Fabulous. This is working well. So x plus 6 squared equals 49. So what number times itself would be 49? What number squared? Don't forget there's 2 of them, right? So x plus 6 either has to equal 7, or x plus 6 has to equal negative 7, because that's our 2 numbers that would work out to be 49. So minus 6 over here, x equals 7 minus 6, 1, minus 6, x equals negative 7 minus 6 more, 1 and negative 13 are our 2 factors, our 2 solutions for that original equation, and also for this equation. It works either way. One more. Let's look and see. Oh, let's do the one that has the big number up here. All right, the big number. So we've got multiple things going on. We've got a number on the other side, and we've got a number with our equation that does not work to be a perfect square, because a perfect square, all right, focused, minus 2 is our middle x term, and if we take half of that, that'd be minus 1. So minus 1 times a minus 1 is not 3, right? It's only 1, because minus 1 times minus 1 is 1. So we've got to move this first. So we've got x squared minus 2x equals 80. All right, x squared minus 2x equals 80, because we subtracted the 3 first. Now we're going to add on our perfect square. So minus 1 times itself is a positive 1, which means we've got to add 1 on that side also. So this side, x squared minus 2x plus 1, the factors are x minus 1 squared. X minus 1 times x minus 1. The other side is 80 plus 1, or 81. So if we take the x minus 1 and we set it to the two factors of the other side, what equals 81 when multiplied by itself? That would be 9 times 9, or x minus 1 would equal negative 9 times negative 9. So let's see. Add 1 in both equations on both sides. Now x equals 9 plus 1, 10, or x equals negative 8. All right, you see how this works? It's not that bad when you get a little practice with it. It comes together pretty nicely. Let me show you. I was going to show you your homework assignment and what it is going to look like before you get there. Okay, we're starting out with, let's raise this up. I want to see more of the page at one time here. More of the page. It's going to start out with adding the number that would make the expression a perfect square. That would make it a perfect square. X squared minus 6x plus what would make that a perfect square? You remember how to do that? We just went over that. You can always back up and look. You're going to take half of this number, and then you're going to multiply that number times itself. You're going to take half of this number, and you can multiply that number times itself to get that space there. So you'll do that in each of those. Take this number, cut it in half, because it would be itself twice added together. Cut that in half and multiply that number times itself to get the last one. So that's not going to be too tricky. Let's look at the next one. All right, so this one, all right, Maya's solving the equation. So here's her equation that she's solving. X squared plus 12x equals 13. So she writes this. X squared plus 12x equals 13. So x plus 6 squared equals 49. So x equals 1, or x equals negative 13. All right, would you understand that? Jada didn't understand that. Jada looked at that. She was confused. She didn't see, how did you get that answer? Well, that's because she didn't put down all the steps. So complete some missing steps. Here's the steps she's missing, right? She made the perfect square and then jumped straight to this step. She didn't put this step in there. This step was missing. And this step was missing, right? She made the perfect square, added to both sides, come up with that. And then from that, she set this number equal to this number and this number. And then from that, when she subtracted 6 from both sides, she got these answers. So you're supposed to fill in those missing blanks that Jada was confused about, and that will help Jada understand that. And it'll help all of us, I think, a lot of it. Our third one, matching. All right? Match the equation to the equivalent equation that has the perfect square on the other side. So I would start here. Say x squared plus 8x equals 2. What would make that a perfect square? What is that number? When we take 8 and we cut it in half, that's 4. Right, so 4 times 4 is 16. Which one of those is going to look like that over here? It's going to be an x plus 4 squared. X plus 4 squared. Looks like it's going to be this one. What number did we add? We said we had to add a 16. 16 plus 2, that gave us the 18. I've already given you one answer in your homework. A goes with 4, right? Because we added 16 to both sides. That's an x plus 4 squared. That's an 18. All right, so that's how you do that on each of these. Figure out what is the number that would be the perfect square factor. All right, what is that number when we cut that in half? And then what did we add to make that a perfect square, and make sure that's what we add to their side. It's not 10 and negative 10. These are not a match. But I'm saying you need to check all of those to see how that goes. That should go pretty well. All right, and then we're going to end up, I'm giving you 3 problems just to solve. And you're going to give me the 2 x's that each of those. So you'll need some scratch paper to work those out. I'm going to give you just what are the solutions. X equals what? And you're going to say -2 and 5, or whatever the answers are. I don't think either of them are -2 and 5. I just threw that numbers out there. So that's what the homework looks like. Shouldn't be too bad. It's some pretty good practice with completing the square. So I'm going to have those posted with this video. If you got any problems, any questions, go back and review this. Let's see. There we go. Hey, all right. Go back and review any parts of the video you need that you may have not quite understood. If you're doing the homework and you're like, oh, how do I do that again? Open up another tab. Pull up the video again. Don't abandon the homework where you're at. Just pull up another tab. Find the part of the video where I go over whatever you're trying to figure out. And, oh, that's right. I got to multiply that number times itself, wherever you're stuck at. But anyway, do good. If you got problems, email us. We are online. Ms. Smith and I are both online every day. We are looking at emails all during the school day. So we will get back with you. And if you put something in the assignment and it says it's wrong, the computer does not do a good job of grading. So I go back and I look at them all. Maybe you put the answers was 4, space, -2. And the computer was looking for 4, -2. And there's an extra space in there. It's going to go, oh, that's wrong, when you have it absolutely right. I go back and I give you credit on those. So don't fret if you absolutely know that's the answer, but it's telling you it's wrong, because I'll go back and look at all of those, make sure you get credit. Anyway, do work I can be proud of, and you can be proud of. Have a good day.